Okay.
Let's see. Um, so it starts off a bit strange, like it's not kind of your usual questions, answer stuff. It
Yeah.
just explains lots of stuff first. Okay. A census is every member of a population. A population is the whole set of items that are of interest. And a sample is a selection of observations from a subset of that population. And it gives you information about the population as a whole. So you have a big block of cheese, you taste a little cube, and that tells you the taste of the entire block.
Yeah.
Advantages and disadvantages for each. A census, it's like completely accurate if you ask questions of everyone in the entire thing,
Yeah.
but disadvantages, you'd have to eat the entire block of cheese, take a long time, expensive. It also destroys all of the cheese. It destroys all the stuff that you use in that case.
Yeah.
And it also creates lots of information to deal with.
Yeah.
If you take a sample, it's like the advantages and disadvantages are the opposite of each other. So instead of being long and expensive, it's quick and cheap. And then on the other hand, the disadvantage is it's not completely accurate. It may not be as accurate as the other one.
Yeah.
And so they're kind of the advantages of one or disadvantages of the other. The size of the sample can affect the validity. Yeah, so a very small sample might not be representative.
Okay.
Because, individual sampling units, sampling frame, sure. Okay, let's give this a go.
Question 8 is because it would destroy all of the avocados.
Yep, and B.
They could double the amount of avocados they use. So instead of 5, they could use 10 for more accurate results.
Increase the sample size.
Yeah.
Great. For example, 2. Okay. Yeah. All right. How about A?
Because it doesn't destroy like the census. That's why you can take samples from everyone, and also doesn't take that long, does it?
So it might, so long as you judge it either way. So you could also say it would take too long to do a census of all 713 members.
Yeah.
And so you could argue it either way, so long as you support it with information. So let's say whether it is suitable to use a census. Let's just say unsuitable, too time consuming.
Yeah.
A sample might be just as good.
Yeah.
And B?
They could use a sample because it's less time consuming.
Yeah. Exactly. Less, and I'll write expensive as well. Less expensive, slash less expensive, time consuming. Okay, fine. Not sensible, too time consuming. Oh, there you go. Sensible. See, they gave both answers. Both answers are correct. It's not sensible
Yeah.
because it's too time consuming. It is sensible. We'll use all of the data, and yeah, it'll give a more accurate thing if you ask everyone.
Yeah.
Yeah. Let's see this one. Grand. Givers of matters conclusions might be unreliable. Session way. I think you'll be fine.
Yeah.
Some of this stuff you can learn. All right. The sampling units. A local council wants to know. I'll let you do this independently.
Okay.
The company claims. Yeah, just do this stuff independently. Okay, you have different types of samples. Simple random, systematic,
Okay.
and stratified. Let's learn about it. A simple random sample of size n is one where every sample of size n has an equal chance of being selected. It's like a lottery.
Okay.
Okay, any idea about A?
They would. So you'd use a random generator so you can get, instead of it being alphabetically, they'd take the names randomly from the generator rather than having it alphabetically.
And so they actually want you to to describe it. And so the way you'd have to do is you'd have to say like number each of the members from 1 to 100.
Yeah.
Then generate 12 random numbers between 1 and 100. Yeah, and do that 12 times and select the members whose numbers come up.
Okay.
Yes, explain that to me. These are lottery sample. Okay, so how would they? So that's a simple random sample, and then how could they do a lottery sample?
Or could they just give one to each member?
Yeah, basically they could like give a number the list from 1 to 100, the names, write a number, or let's say they could write just the name of the person on a ticket. Put 100 tickets into a box and take 12 out randomly.
Yeah.
100 in a hat. Okay. Yeah, so they're just describing what it is.
Yeah.
In systematic sampling, the required elements are chosen at regular intervals. So systematic means they follow a system. And so only the first person is random. And then the system is every 20th person or every 5th person. So 4 to 5, 4 to 5. And only the first person is random. Stratified sampling is representative of the overall population size given some kind of characteristic.
Yeah.
So if a quarter of the population are men, then you could do a quarter of the sample are men. Something like that.
Yeah.
Okay, so let's try this one.
So do I need to divide the ages?
What do you mean?
Or would it be like, would you need to work out the age between 32 and 18 first?
No. I would work out. So there's 80 workers.
Yeah.
Oh, sorry, there's a sample of 80. What's the total number of people?
75.
Total number of workers.
Oh. 300.
Okay. So you want a sample of 80 from a population of 300.
Yeah.
And so, any idea how you use that?
Would you need to divide 300 by 80?
Divide 300 by 80?
Yeah.
I think let's do it as like 80 other way around. 80
Okay.
divided by 300.
Which is 0.26 reoccurring 7.
And what is it as a fraction?
4/15.
Okay. So 4/15ths.
Yeah.
And so, any idea how you'd work out in your sample how many should be between each age?
No.
It would basically be, well, if you wanted, let's say, a sample size of 150, that would be half of your total population. And so you would just cut each of these in half. This is 4/15ths of the population. And so you just want 4/15ths of each group. So 4/15ths of the sample should be in the first group. So it'd be that many people.
So it's 20 for the first one.
Yeah, so we want 20 aged between 18 and 32.
Yeah.
What would you do next?
140 would be 37.3 reoccurring.
So let's say 37 people.
Yeah.
Okay.
And the last one is 80. The other one is 22 or 23 to one whole.
Yeah, so we'll round that to 23. And if we add those up, we would get 80.
Yep.
And what is the name of this one? Do you remember?
What, like the way we found the answer?
Yeah.
Systematic?
This one is called stratified.
Stratified, yeah.
These are called strata.
Yep.
The age group is the stratum. All three are strata, and this is called stratified sampling.
Okay.
If you ever see those sampling, these experiments with worms in them, a worm in the worm tank, and they've got like, this is clay, then there's rocks, then there's sand, and then after 2 weeks, it's all mixed up because the worms mix it up.
Yeah.
These are different strata. And
Yeah.
these are different strata, it's called. Great. Okay. There are advantages and disadvantages to each of these types of sampling. And the advantages of one are disadvantages of other. Simple random is free of bias, so it's unbiased, easy, cheap, quick, that type of thing. Not suitable when this population is large and you need some kind of sampling frame, so you need like the name of everyone or something like that. Stratified sampling is kind of the opposite. It's not quick, it's not cheap, it's not easy, but it's more accurate, that type of thing.
Yeah.
I just don't want to spend a lot of time on it. A dance. Okay, how about A?
So would you say like you could take 20 from each? It's easier because you can take a sample from like both boys and girls.
I think just it's like
in total, right?
I think the question is referring like advantages of simple random sampling as opposed to a different type of sampling like stratified sampling.
Oh, it's not like complex.
Yeah.
Because stratified sampling is way more complex.
So it's simple. One more.
And it doesn't follow any like rules.
All right. What's the advantage?
Like for systematic, you don't have to like go through all of the.
How is it an advantage that it doesn't? That you don't have to do those
Because you
things.
can just pick them at random. You don't have to like pick certain
How is
things to.
how is that an advantage? What is advantageous of that?
Requires less work.
There you go. Simple, less work, probably quicker,
Hmm.
probably easier, whatever. Yep. So don't just describe it. Actually, you have to say like an advantage of it. Let's see. B.
Okay. Would it be less accurate
Why is that?
compared to say like stratified sampling where you can use it on everyone rather than say like 40 people.
Stratified sampling also takes a sample, not everyone. So that's like a census versus a sample.
Yeah.
I think it might be because if you just pick people randomly, you might get all 40 are boys, something like that.
Yeah.
So it might be, you might get an unrepresentative sample. Yeah,
Yeah.
I should use the word unrepresentative. Unrepresentative. It might give you an unrepresentative sample, because it's just random. Okay, and see.
Teacher can add the boys and the girls together and then divide 40 by the total, which is 200.
So go on, do it.
Okay. So it'd be 75 divided by 200, which is 3/8.
Mm-hmm.
And then do you multiply 3/8 by 40?
No.
So do you need to like minus 40 from 200?
No. How many boys? How many girls? And they need to
75, 125.
Okay, so that adds up to 200. We need our sample to add up to 40, but still be in that proportion.
Okay.
So our sample is 3/8 of the population.
Yeah. So could you divide them all by 5?
That would be a fifth of the population.
No, I meant like 75 divided by 5 is 15, and then
That would be a fifth of the population.
so you times 3/8 by 75 and 125.
Correct. Yeah, we want 3/8 of the boys, 3/8 of the girls.
So the boys is 28.125, or just 28.
Yeah.
And the girls is 47.
Let's see. And does that... No, 47. They need to add up to a sample size of 40?
Yeah, I times the 125 by 3 over 8 and I got 46.875.
How did you get 3 over 8?
You multiply 3 over 8 by the population
Okay, where did 3 over 8 come from?
at the bottom.
Where did 3 over 8 come from? What numbers?
The sample is 3 over 8. 3 over 8 the population.
No. The sample's 40. 40 out of 200. Now you're making sense. So a fifth. That's where you're getting a fifth from.
Okay.
No. Yeah, it's a fifth of each.
Okay.
Now I'm less confused.
So you get 15 for the first one.
Yeah.
Which is for boys. And for the girls you get 25.
That's it. Okay, great. Yes. Grant. So yeah, the sample is a fifth of the population. Sample size is a fifth of the population, so it's a fifth of each. And the teacher. So they said explain how the teacher can take a sample. They actually didn't. I think they didn't want us to do this. They wanted us to explain how you do it.
Yeah.
But I thought we should just do it. Oh no, there you go. Yeah, they wanted the explanation. Great. Okay. All right. I have to do one. Let's just do A.
Okay. How do you do systematic again?
So you're just asking me to tell you the answer. It's basically you have to follow some system, but you start from somewhere randomly. So you pick you number everyone, pick a random number, start from that employee, and then you go, let's say, count 10 forward each time. Oh, hang on.
Okay, so you could.
How many forward would we count each time to get a sample size of 35?
5.
How'd you get 5?
Well, you could just do 5 at 5 and then add 5, 5, 5 until it gets 35.
I think what we need to do is 700 over 35.
Okay. I got 20.
Okay, so I think we should take every 20th person. So you start somewhere randomly and you take every 20th person. And if you were to, the 21st person would be like back to the start again. You know what I mean?
Yeah.
Yes. And then how about part B?
The disadvantage of a systematic sample was that you don't get people in between the zeros, so you don't get like 1, 2, 3, 4, 5, 6, 7, 8, 9 as the last number.
Yes. And so what type of sample would you get?
Pardon?
So who would be in the sample, or what type of sample would you get?
You get a bias sample.
Correct. You might get all employees, or you might get all managers. If your random number, starting number is, let's say, 30,
yeah,
then it's going to be 30, 50, 70, and so it'll be all managers. Yeah. Sampling frame is not random, so the sampling method can introduce biased sample. You get the idea. Great. Sample size of 50. I'm sure you'll figure this stuff out. Okay, sampling.
What will it take?
Yeah, I don't want to spend much time on that. Non-random sampling. Quota sampling. Quota is similar to that. It's like we need, 10 boys in the sample. So it's like when you reach 10, then you stop. Make sure you get 10, that type of thing.
Yeah.
Opportunity sampling is like the first 20. The first 20 who walk out of the shopping centre. So you do it that way. There's advantages and disadvantages. Okay, how about 3A?
Okay. So could the coach? So does the coach want 5 people, right? The highest.
5 people. Yep. Opportunity sample.
So could he? See how many. But you can't really do. Can you do it for height? Could you like line them up and see who's the highest?
Yeah. Opportunity sample. Let's say first 5 who walk in.
Okay.
Who walk in. Some of that. Okay. One disadvantage.
A bunch of tall people could walk in first, or a bunch of small people could walk in first.
Yeah. So I would give an unrepresentative sample.
Yeah.
Or biased sample. And an alternative you could use.
Quota sampling.
Quota. One from each group or something. Could be stratified. Take a simple random sampling and select these players from a numbered ordered list. Okay. Take the first 5 players. These players could be the 5 shortest or 5 tallest. Okay. Great. Okay, what is A?
Okay. They used opportunity sampling.
Yeah.
It's not that reliable because they only ask for the first 4 people. So the 4 people might not have watched the cinema. They might have been there to like drop someone off or something.
Yeah, I'd say it's like definitely biased. Like maybe people who who like movies, watch TV like more than average. Something like that.
Yeah.
Some other reason? Any other reason why? Not a good sample? Or how could you improve the sample?
You could use like simple random sampling.
I think it's a very small sample size.
Okay.
Like 4 people, you should ask more.
Yeah.
Oh, that was part B, I think. Okay, take a larger sample. Oh yeah, vary the time, day, location. Great. Let's see this one. Oh, okay. How could we do A?
Okay. What does it mean by quota sample?
Quota sample. They have to meet some kind of quota. An interviewer or researcher selects a sample that reflects the characteristics of the whole population. So it's a bit like...
So could you add the female and male drivers together?
Yep.
which would give you 350.
Mm-hmm. What would you do with that?
And then would you take 70 samples from it?
Okay, what do you mean by that?
Like out of the mix between male and female drivers, you take 70 out of it. You take 70 female and male drivers out.
I believe it would be like the sample has to be 73/50ths of the population.
Okay. Which is a fifth.
Yeah. And so, how could you get a quota for male, quota for female?
Would you multiply it by male and female 150, 1/5?
Yeah.
So for male it would be 30 drivers. And for female it will be 40 drivers, which gives you 70.
That's great. So it's very similar to the other one. Yeah, 30 males, 40 females. Non-random.
Probably between a tick and a half.
Okay, types of data. Sure. Qualitative and quantitative. Quantitative, quantity, numbers. Qualitative, quality, words. Red, green, blue, that type of thing.
Yeah.
Variables, sure. A variable can be continuous or discrete. If it is continuous, it can take any value in a given range. 2, 2.1, 2.01. A discrete can only take certain specific values in a given range.
Yeah.
So a shoe size can be 5, 5.5, 6, 6.5, but it can't be 6 1/3. That doesn't exist.
Yeah.
Data is presented in a grouped frequency table. Yeah, sure. Okay, here's a grouped frequency table. Okay, let's try these.
Is this quantitative data?
This is quantitative data because
Yeah.
length. It's a number.
Yep.
Okay.
And is it continuous?
Length is continuous. Yeah. Any idea about B?
Okay. Would the midpoint be 35?
You would think so. However, because it's continuous data, you need to these have been rounded, so you need to unround it. So, for example, the very first group, if the length of the wing of a butterfly was 29.5, they would have rounded it up to 30. And so that group is actually 29.5 to 31.5, not including 31.5, but including 29.5.
Yeah.
And so something similar for the 34 to 36 one.
So it'd be 33.5 and 36.5. 4, sorry.
And 36.5.
Would it be 4 or 5?
I
5.
write it without the or equal to.
Oh, okay, yeah.
Because it could be 4.49, you know.
Yeah. And then what? So is that the boundaries?
Yeah. And now we want midpoint of that.
The midpoint would be 34.5.
Add the two together, divide by 2.
Okay. I got what? Wait, 33.5. Okay. Divided by 2. I got 35 exactly.
So midpoint is 35. Class boundaries, midpoint, and class width.
I've got the equation for class width. There's a certain equation, isn't there?
No. Upper bound minus lower bound. So
Okay.
here it would have been 2 from 34 to 36.
So the midpoint is 3. Not midpoint, the class width.
Yep. Class width equals 3. Great. Cool. Let's see this one. All right. What is B part 1?
Okay. Uh, 44.5 to 50.5.
Hang on. I don't think so. I think this one is actually, there's no gap between them.
Oh, right. So it'd be 45 and 50. Between 45 and 50.
Yeah, I believe 45, 50. Yep. Let me see this one. Researcher. Stratified sample. Okay. That's fine, I think. And then you have the large data set. So do you know how the large data set works? Have you heard of that?
No.
So you need to answer questions based on real data in your exam, and that data will come from weather data, so real world weather data.
Okay.
It's weather data samples. The UK, let's see, May to October 1987 and May to October 2015. And the weather stations are located in these places. So that's like Scotland, Midlands, south, east, southwest, south of England. Then you have Jacksonville in America, Beijing, and Perth in Australia. Yeah, and so, and large data set. It's like a big spreadsheet of data.
Yeah.
You have to kind of understand what you're looking at. You'll be asked to, like, here's some real world stuff. They might say compare the average temperature in Hearn with the average temperature in Perth.
Yeah.
In May to October 1987 or something like that.
Yeah.
You have to make sense of it. So daily mean temperature is the average temperature for the day. Daily total rainfall, daily total sunshine, daily mean wind direction and wind speed. They are measured in knots, and you have a thing called the Beaufort scale. Okay, knots, nautical mile. Daily maximum gust, so the maximum wind speed for that day. Daily maximum relative humidity. So a very high humidity means it's very foggy. Very, very low humidity, very little water, moisture in the air. Daily mean cloud cover. So there isn't that much cloud, or there's lots of cloud. So visibility, how far you can see, maybe due to fog and stuff. Pressure, air pressure. Okay. That's fine. So you can see here they give you an extract of the actual real world data to give you. Okay. Let's do A.
Okay. What does it mean by just like the data represented?
Numbers, information.
Well, so it's like the mean amount of rainfall in millimeters.
The type of data, discrete, continuous,
All right.
quantitative,
Is it
qualitative.
is it discrete?
Let's see. The type of data, daily. Total rainfall is measured in millimeters.
Oh, so they keep going up, so it'd be continuous.
So that one there, yeah, because it can be a decimal, it can be whatever. So that one is continuous. And is it quantitative or qualitative?
It's quantitative.
Yeah. Okay. B.
Is she using simple random?
Very good. And a new ability.
Okay. Because if she selects a random numbers between 1 and 20, she might not get a sample of 5 for the first 20 days. A size 5 for the first 20 days.
Okay. Why not?
Because she's got 1 and 20 to pick from between them numbers. They
Nope.
might not be the first 5.
Not the first five. 5. They're saying
No.
she might get a sample size of 4, even though she picks 5. Why is that?
Because maybe not every day has gust in it.
Kind of. So there's a difference here. The gust was 0.
Yeah.
Here it is trace.
Yeah.
Oh, gust. Was this one for gust?
Maximum gust.
Where is gust? That's
On
the
the right.
last one. Yes. It's because it might land on this one. NA.
Yeah. Not assessed.
I believe that means that there's no data available on that day.
Yeah.
Not really. Not applicable. Is that the same as 0? I think, let's see. Some of the data values are not available. So that stands for not available. So maybe the data has been lost over time or something like that. But the data is not available. Yeah. And so if you see that NA in the data set, you need to know that that means that the data for that day is not available.
Yeah.
Okay. Let's see. We have another one. Use the extract the daily mean temperature for the first 5 days. How would you do that?
So you'd add all the temperatures together and divide by 20.
For the first 5 days?
Of the first 5, you add the first 5, then divide by 5.
Well done. That's fine. 1, 2, 3, 4. Yeah, add those 5 up, divide by 5. The median.
Okay. So you get to you look at the 14th, and then you get 10.2, and then you do 12.6, and you count. Do you add it together and divide by 2?
Median. Do you remember how to find? Oh,
You add them together and divide by 2, right?
Well, how many things are there?
Oh, 0 and 0.
No. How many days are there?
Uh,
So that's a week, is it? So 7 days.
yeah.
So you would do 7 plus 1 over 2.
Which is 8 divided by 2, which is 4.
And so it's the fourth value if you put these from smallest to biggest.
Yep.
And so what is the fourth value if these are put smallest to biggest?
Okay. Where would you put trace?
Trace means very close to 0.
Okay. It would be 0.1.
Well done. And so that one is 0.1. That's B. And then, okay, how about C? So that was median daily total rainfall in Herne, which is in England.
Yep. It doesn't support the statement.
Why not?
Because in Perth it was 19 millimeters of rainfall, and for the same week. But in Herne it's 4 millimeters, the median of rainfall, meaning that there's way less in Herne than Perth, even though they're both in the south.
Let me go back. So Herne is here.
Perth all the way in Australia.
Yeah. And so do southerly countries get more rainfall than northerly countries?
Perth is south, which is Australia.
So you would think so, but my guess is that maybe you're comparing. When was this?
1987, I think.
Let's just see. May to October. So that's like summer.
Yeah.
You're comparing the summer in Herne to the winter in Perth.
Yeah.
And so maybe you're not comparing like for like. Maybe you need to compare the summer in Herne to the summer in Perth, or the winter in Herne to the winter in Perth, because it's there. Perth is in Australia, which is south of the UK, and the median is that. However, this is a very small sample from a single location. Each country so does not provide. Oh, so it was just a small sample size.
Yeah.
So yeah, your reasoning was correct. It was just a small sample size. All right. Great. Let's see. Delilah is interested in how this one. What would be A part 1?
Okay. The sample size is really, really big, so she only chooses 5 days. It's better if she chose more than 5 days because there's such big samples.
Yeah, and her choices of location?
Heathrow and Herne are really close to each other. They're in the south. You'd
Great.
rather take one in like Scotland.
Great. Yeah, they're very close to each other.
Yeah.
Windows 15. During her sampling, Delilah selects the same data twice. Okay, yeah, so she takes a simple random sample, but she gets the same thing twice. So how could she deal with that?
She could do it again.
I think she'd have to change her thing. The sample should contain 15 different dates. Data values cannot be reused.
Yeah.
She should therefore reject the repeated value in the random and generate a 16th. Oh, so she should just skip it and take another one.
Yeah.
Okay. Let's see this one. Jerome, Lucas, and Camborne might be lower. So a geographical reason why the daily mean temperature in Lucas might be lower than Camborne. Any idea about that one?
Is it because Luch's is all the way in the top of the...
Yeah, it's it's more northerly, so it's closer to the North Pole, further from the equator. And criticize his sampling method. Maybe it's small sample size. Yeah, very small. Lucas is further north. Great. So this is the type of question they seem to be emphasizing geographically and stuff for this real world maths. Let's see. Explain. How do you take a systematic sample?
You have like every number, it goes up in every like number. So say if it goes in fives, it'd go like 5, add 5, add 5, add 5, add 5.
Where do you start from?
You start from 20, right?
You start from a random number.
Okay.
Random place. Let me just see. However, this is for daily total rainfall in Leeming in 2015. I'm trying to see. Did we see one for 2015 somewhere? Let's just assume they're all the same. Leeming. This gave us 20 days. So if they wanted a sample size of 5, they'd start somewhere randomly and go up in 4 each time. So 4, 4, 4, 4, 4, and that would be 20. That would give a sample of 5, I think. Let's see. What is question B? State the meaning of that.
It means that the value is very, very close to 0, but it doesn't get to 0.
I think it's trace, and so it's like, okay. And how could she deal with that one?
She could just write it as 0.
All right. Let's see. So she generates a random starting number, then counts on every 9 dates. So there was 184. Yeah. So maybe we need to look up the spreadsheet for that. I don't think we do. We'll see.
Yeah.
TR means trace, which is less than that. Any data could be recorded as 0. Okay. Let's see. Jagdeep. He did an average and got 31 knots and 25 knots. Explain why he must have done something wrong. Any idea how you know how he did something wrong?
Is it because he went... Because the Buford scale says it goes up to 5 and the 5th one goes up to 21 knots, but on his data it goes above 21 knots.
Yeah. Which is more than the maximum.
Yeah.
The correct value is 11 knots. And so what is that in the Beaufort scale?
It's like 2 or 3.
11 knots.
Yeah. I know, it's 4.
4. Yeah. Did you ever do sailing?
Pardon?
Did you ever go sailing? Did you ever sail a boat?
No.
It's good fun.
Oh, but you use knots, don't you? Yeah.
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 And then this one. Okay, we've got 2 things. The average temperature is 16.8. 26.8. So using your knowledge of the large data set, any idea which weather station is, let's say, B, had the highest average temperature, C had the lowest?
Beijing,
Why is that?
I think. Beijing, or I think it might be.
Beijing, yeah, you're right.
Yeah.
Great, and so you can do that. Let me see. Systematic sampling. Oh, so here they actually told you 184 days. And they wanted a sample of 30.
Yeah.
So what would you do there?
So would you divide 30 by 184?
Yeah, 184 divided by 30.
And then you multiply that by 184, right?
Then it would go back to being 184.
Oh,
Basically, it would be what answer do you get?
I got 15 over 92.
15 over 92.
Yeah.
Sorry, other way around. You were right. 184 divided by 30. What do you get?
Okay. I got 92 over 15.
Press SD.
6.13 reoccurring.
So let's say start in a random position and go up by 6 every time.
Yeah.
Yeah. Start a random day and then every 6th thing. Okay, we made it. And so chapter 1, what do you give yourself? Hey Adam?
I'll be back. You froze for a second.
Yeah, how was that for you?
That was great.
And so chapter 2 next time?
Yeah.
Great. Any questions in general?
No.
All right, well done, Adam. You did great.
Thank you.
And look forward to talking again next time.
You too.
All right.
Bye.
Have a good weekend. Goodbye.